Hello, this is Mrs. Poland, Unit 2, Day 8, Solving Radical Equations. A radical equation is an equation which contains an equal sign, and there's going to be a variable, and it's going to be hiding out under the radical sign. So this left-hand side equation is a radical equation. We notice the variable is under the square root sign. The equation to the right is not a radical equation because although there's a radical in it, the variable is not under the radical sign. These are the steps to solve a radical equation. You first need to isolate the radical so it's only on one side of the equation. If the radical is a square root, you're going to square each side. However, if it's a cube root, you're going to cube both sides. If it's a fourth root, you're going to raise both sides to the fourth, and so forth. You're going to end up with an equation that's either going to be linear or quadratic, and you're going to be solving that equation. And then it's really, really critical to check because sometimes you're going to have these answers that look correct, but when you actually check them, it's not going to be correct. So here's our first example, and the first thing I'd like you to do is rewrite the equation so it's easier to follow your notes. We notice that the radical is isolated, it's by itself, so the next step would be to square both sides since this is a square root. When we do that, the radicand comes out, and 5 squared is 25. This is a linear equation, so I'm going to add 3 to both sides of the equation. We get 2x is equal to 28. We divide both sides by 2, and our final solution is 14. But we need to check this equation, so we're going to check in the original. So wherever you see an x, you're going to replace it by 14. We get 28 minus 3, which is 25. And yay, it works. We put the final answer into brackets. In problem number 2, notice that the radical is not isolated, so the very first step is to isolate it by subtracting 7 from both sides. This is a square root, so we're going to reverse the operation by squaring both sides. We get 2x plus 5 is equal to 9. It's a linear equation, so we're going to subtract 5 from both sides. And now divide both sides by 2. We're going to now check our solution in the original equation. This becomes square root of 9 plus 7. And yay, it works again. Our final answer is placed in a solution set, and we're off to the next problem. Again, let's restate the problem so it's easier for us to follow our notes in the future. Notice that the cube root is isolated. So the next step would be to reverse the operation, meaning we're going to cube both sides. Notice that I have negative 2 in parentheses. My left-hand side becomes 4 minus 2a, and my right-hand side becomes negative 8. I solve the resulting linear equation. we get a solution of 6. And so the next thing I want to do is check my answer in the original problem. And lo and behold, it works. Great job, everyone. Again, put your final answer into a solution set. We're going to skip to example 5. The very first thing you're going to do is isolate the radical by subtracting 1 from both sides of the equation. We get x minus 1 is equal to the square root of x plus 5. We then square both sides. And the right-hand side is easy. It's just x plus 5. The left-hand side, what does this really mean? It means x minus 1 times x minus 1. So we're going to actually have to FOIL this, or double distribute. I'm going to just do this on the side. We get first times first, outer, inner, and last times last. We combine like terms, and so the left-hand side is equal to x squared minus 2x. Be careful, because often students will write this as x squared plus 1. I call that the fatal error, so just make sure that you expand this out properly. Notice that I now have a quadratic equation, and so therefore I need to put it into standard form. And to do that, I'm going to subtract x and subtract 5 from both sides of the equation. I get x squared minus 3x minus 4 is equal to 0. I'm going to factor this now. And solve for x. Both solutions need to be checked in the original equation. You could see that the check that I did for x equals -1 didn't work, so we reject it. We didn't reject it because x is equal to -1. We rejected it because when we replaced the solution in the original equation, it didn't work. Be careful about that, because sometimes the negative does work. We then checked x equals 4, and we noticed that it did work. So the only solution in this problem is x is equal to 4. I'm going to do one last problem with you, example number 8. And this problem is a little bit different because you can see that there's a radical on both sides. So how do we end up solving it when we have a radical on both sides? Let's rewrite the equation. Let me just get a pen out. And when we square both sides, that's annoying. Just give me 1 second. I don't know why I'm getting that eraser. It's annoying. Well, I'm going to ignore it. Please ignore it as well. So when I square both sides, my left-hand side becomes x squared plus 4. And my right-hand side, you also have to square the 2, not just what's under the radical. And notice I put parentheses to remind myself to distribute that 4 to both terms. I get x squared plus 4 is equal to 4x plus 16. This is a quadratic equation again, so I'm going to subtract 4x and subtract 16 from both sides of the equation. I get x squared minus 4x minus 12 is equal to 0. The factors turn out to be -6 and +2. Set each linear equation equal to 0 and solve. We're now going to check both solutions in the original equation. You can see from the check that both x equals 6 and x equal -2 both work, and so that goes in the solution set. Notice, just because you have a negative x solution does not mean that you reject it. In this case, it works. I hope that this video was useful. See you tomorrow.